Good morning, guys. Hope everything's going well. Hope the parabolas from the other day felt okay on my lab math and everything. Stop by the office hour today if you have any questions on the parabolas we did on Tuesday or the ones that we're going to look at today. The nice thing about today is that everything from Tuesday still applies. We're just adding one new thing, right? So this is the formula we saw on Tuesday for the vertical opening. This is the formula we saw for the horizontal. The only new thing we're adding is an h and a k, which you've seen before. All right, these are like a transformation. Okay, the h and the k are going to be the vertex. So you can see here, instead of x squared, we have x minus h squared. Instead of just y, we have y minus k. Okay, so the vertex now is not going to be 0, 0 all day. It's going to get moved around and go wherever hk is. For the horizontal one, again, instead of x, you have x minus h. Instead of y squared, you have y minus k squared. So your vertex is hk. Now, one thing to watch out for, minor trick here, is that the h is over here and the k is over here for the horizontal, right? The x value of the vertex is always by x, and the y value of the vertex is always by y. So for this bottom equation, watch out. It gets flipped. H is to the right, k is to the left. Up here, h is left, k is right. So usually students are okay with that one. But that's it. The a value does the same. The a value takes us to one way to get to the directrix, the other way to get to the focus, and that's it. So let's try a few here. We want to find all the missing information and include 2 points that determine the latus rectum. Okay, so no equation for this one. This is one where I gave you the missing information. I tell you the focus is at 3, 3. So 1, 2, 3, 1, 2, 3 is right there. Again, I'll put a little f there to remind myself that is the focus. The directrix is y equals negative 3. So that's down here. At y equals negative 3. So we need the vertex, right? Now, we haven't seen one like this. I think we saw one on Tuesday maybe, but not a lot. The vertex, if I give you the focus and give you the directrix, the vertex has to be smack dab in the middle somewhere, right? Directly in between them. So if, sorry. Let's try that. There we go. Where am I? There we go. Sorry. So the vertex has to be halfway between the focus and the directrix. It's got to be right there. Okay? So the vertex is 3, 0. Now, once you have the vertex, and once you have the a value, which you should be able to see here is 3, right? The distance between the focus and the vertex and the vertex and the directrix. Once we see that's 3, we can come up with the equation. Now, you do have to know these equations. I would just focus on this one and this one. Because if you know those two, you can go back. If the vertex is 0, 0, then the h and the k just go away. But you do need to know those really well to be able to come up with these. Now, I can look at this graph. I know it's a vertical opening, so it's up and down like that. Those are the ones we saw last semester, so those are the x squares ones, or the x squared parabola. So I need x minus something there, squared, equals, it's going to be positive because it's going up, 4 times a, remember my a is 3, so 4 times a is 12, parentheses, and then y minus something. Okay, so that's how you set it up. Same setup as Tuesday. The only difference is now we have h and k values. So x minus 3 and then y minus 0. Now the y minus 0 is optional. Of course, you could just have 12y on the right side, but I'll show you the full form here for these. All right. Now, lattice rectum points. Remember, this 12 is the key to find the lattice rectum points, the focal width points. I know the focal width here is going to be 12, so starting at the focus, I'm going to go left and right 6 units. So right 6 units takes me to there. Left 6 units takes me to there. And I can put those points as xy ordered pairs. So 9, 3 and negative 3, 3. So kind of a weird thing about conics is that we graph these without using a table of values, right? First semester was a focus on functions and tables of values and everything. Conics, though, we take the equation and what we know about the a value and the h's and k's and all that stuff, and we sketch a graph. We get points without ever even using the equation much, without using an xy table much. Okay? All right, let's go the other way. What if I gave you the equation and just wanted you to come up with a graph? Now, be careful. That is not the correct form. Look back at the front page here. This 4a and this 4a have to be out in front of the y, kind of like that b value for semester, and like the b value with the trig functions. We always have to factor that out. So that is not what I want to see when I go to graph this. I want to take that negative 12 out. So I'm going to write it right above it, y plus 2 squared. Let me fix that plus sign, that looks weird. Let's just start over. So this is y plus 2 squared. I'm going to factor that negative 12 out, and it gives me x minus 2. So watch out, that it has to become a minus 2 because you factored out a negative 12. Now the vertex here, kind of like our horizontal transformations, the standard form is x minus h. So when I see that x minus 2, that's 2. So remember, that's the h value there on the left, on the right side by the x value. So 2 comma y plus 2. The standard form is y minus k, so that's really a negative 2. So watch out for the signs there. Those signs for h and k work like those horizontal transformations because the standard form here have minus signs in both spots. Okay? All right, so there's the vertex. A value, right? I got the 12 there, so 4a equals 12. You don't always have to set up that little equation, but it helps. A equals 3. So now I can plot my vertex at 2, negative 2. I can use my a value to find my vertex. Now, you also have to know which direction this is going. Because this is a y squared, y squareds are the weird ones that we haven't seen a lot of. Those are the horizontal ones because they're not functions. And because it's negative, it's opening to the left. Right? That's important because I know the focus has to go inside, and I know the directrix has to go over on the other side. Okay? So it's always important to maybe at least visualize what the graph's going to look like. So starting at my vertex, 3 units to the left is going to take me to my focus. So that's at negative 1 comma negative 2. And then 3 units to the right is going to take me to my directrix. So this is at x. Remember, vertical lines are x equals, horizontal lines are y equals. So x equals 5. And then that's most of the graph. I just have to finish and find some lattice rectum points. So some focal width points. My 4a is 12 again, so from the focus. Now be careful, don't go from the vertex. The focal width points go from the focus, which is right there. And it's going to go up 6 and down 6 from there, so up to here, right? And down 6 to here. We can go label those points now as negative 1, 4, and negative 1, negative 8. All right, and now we can sketch a problem. Again, try to make these as symmetric as you can. We'll be doing these by hand. Oh, I did not want that to happen. Hold on. Let's do this. How's that one? Yeah, it's pretty symmetric. Okay, and there's an example of doing it by hand. All right, let's try another one. Now, this is going to be an important skill here with conics. This equation here is a parabola. I'll tell you how I know that in a second. But whenever you see conic equations all multiplied out like this, we want to make them look like these. In these forms for conics, and this is parabolas, but we're going to be doing this with all conics. These forms we can know a lot about the graph, where the vertex is, where all the information is. So the way to do that is completing the square. We got to complete the square here to make this equation look like one of these two guys. All right, now with parabolas, here's how I know it's a parabola. I see a y squared. I only see an x to the first power. They're not both squared. You're going to see next week when we start doing ellipses and hyperbolas, they have 2 squared variables, an x squared and a y squared. So that's the easiest way to tell that this is going to be a parabola. There is just one squared variable. Okay? Now, I'm going to get the y squareds, or I should say I'm going to keep the y squareds, the y variables on the left-hand side, because look at your standard form. Y squareds over there. Okay? And then I'm going to add the 4x over and keep the 9 there. All right? Now, completing the square, same thing we've done a few times this year. You take this b value, you cut it in half, you get -3, and you square it. So you're going to put a plus 9 right there. Now remember, you change the left side of the equation, so now you got to change the right side. You got to come over here and put another plus 9 over there as well. This left side now is factorable. Now you don't have to take any time and do AC method. It's always going to factor to whatever half of your b value was there. So half of that is -3. On the right side, I have 4x plus 18. And now I'm almost ready to start graphing this. I have one more step here. I've got to take the 4 out so that it's in the right form. So this is y minus 3 squared equals 4, and then x. Now you have to take that 4 out even if it's not a perfect factor. So remember, factoring is dividing. I'm dividing 18 by 4, which gives me a plus 9 over 2. Distribute that back in. Again, taking out a GCF, the easiest way to check it is to put that 4 back in. 4 times 9 halves is 18 over 4. That's how I know I got it. I'm sorry, not 4 times 9 halves is 18. So that's how I know I factored that out correctly. All right? So there's the form. From there, I'm going to do the graph now, okay? So if you want to, let's pause it really quickly here and try to take this information, put it into the graph, try to see if you can figure out which direction it's opening, what the A value is, all that stuff, and then I'll do it here really quickly so you can check it as well. Okay, so the vertex for this thing is -9 halves, comma 3, right? Straight from the equation. Be careful, the h value's over by the x, so that's kind of in a flipped order here. I think in your head that this thing is going to the right. It's a y squared equation, so it's a horizontal opening, and because it's positive, it's going to the right. Okay, so -4.5 and 3. There's my vertex right there. The focus, right? So this 4 is my 4a. That's okay. 4a equals 1. I'm sorry, 4a equals 4. So a equals 1. So from my focus, to get my focus, I go 1 to the right from the vertex, and I go 1 to the left to get my directrix. Okay, so that focus, if I add 1, right, to this, you can do fractions, you can do decimals here. -9 halves is -4.5. So if I add 1 to that and go to the right, that's going to take me to -3.5, comma 3. Decimals or fractions are fine. If I go 1 to the left, so -9 halves minus another 1, -4.5 minus 1 more is going to give me x equals -5.5 as my directrix. The focal width points from the focus, right? The lattice rectum focal width is only 4 units long. So I'm going to go up and down 2 from the focus and label those points. Those are both at -3.5. The x value stays the same, so -3.5, 5, and -3.5, comma 1. Those are my 2 points, or my 2 points that determine the focal width, or the lattice rectum. And now I can sketch a parabola. And there it is. All right, that's it. So we got to be able to complete the square. Okay, 2 more quick things. Let's practice completing the square one more time. Take a second and pause the video and see if you can't complete this square to get this in the right form so you could go graph it. We're not going to graph anymore, but take a second and complete the square. All right, so hopefully you paused the video and tried it. First step here is to get the 6y out of there, add it to the other side. And by the way, today you're going to know we're only doing parabolas, but pretty soon you're should be able to recognize, because I see x squared and I see y to the first, only one squared variable, I know it's a parabola. Okay. So completing the square. Let's figure out what goes in that blank there. Half of 4 is 2. And then when you square 2, you get plus 4. I've got to add that to the other side. So on the left side, x, again, don't have to waste any time. Factoring is always going to be half of your b value, so x plus 2 squared. On the other side, I got 6y minus 6. And to get it in the correct form, though, I have to factor out that 6. So x plus 2 squared equals 6, y minus 1. And that is the form I'm looking for. All right. Now, one thing I want to show you here, what's the a value of this? Sometimes the a value is a little harder to see, and that's why I've been showing you this little formula. 4a is always going to equal this number right there. So 4a equals 6. A, divide both sides by 4, and reduce, you get 3/2. That's okay. That's possible. Sometimes your a value is going to be a little bit uglier. It might be a fraction or a decimal, but you deal with it the exact same way. All right. Last thing I want to show you. What if I asked you to come up with an equation? Now, we did problems just like this for a semester, but now we're wanting you to do it using the conic equation. Because this guy's opening up, right? I know I'm using this formula, the x squared one. X minus h squared is going to be a positive 4a because it's opening up, and y minus k is going to go there. So like I said before, you got to know these formulas really well. Now, what I know here, I know this point here is hk, okay? So that's going to be able to fill in. I don't know the a value, but I do know a point on the parabola. So if you remember first semester, we knew a point on the parabola, and you can do this for any function, not just a parabola. If I know an xy point, I can use that to plug it in to the equation and find anything that's missing. So let's do that here. All right, so here's my equation. I don't know what a is, so I'm looking for that. I do know that hk is 0, -2. So I'm putting a minus 0 here, and a minus -2 is going to be a plus 2 there for k. I also know an xy of 2, 0, so I know x is 2, I know y is 0, and look, the only missing variable is a. Over here on the left side, I just get 2 squared is 4. On the right side, I get 4a times 2. So I get 4 equals 8a. So I get an a value of 1/2. All right. Now, that's not the end. Remember, this is asking for the equation of the parabola. So now I got to go back up to the very top, fill in the h and k, so x minus 0 squared. Again, that 0 is not optional, 0. Now look at this, 4 times a. 4 times 1/2 gives me 2, right? So that's what goes in front of the y minus k. And then y minus k is -2, so that's going to be a plus 2. This is what the equation should look like. Only x's and y's in the final answer, but I had to do a little bit of work there to find the a value. All right, that's it, guys. Let me know if there's any questions. Stop by the office hour if needed, but we're doing the online homework, My Lab Math, 10.2 day 2. Again, it's got a few graphs using the computer program. It's not horrible. Hopefully you're getting used to it a little bit. Again, I prefer graphing by hand, but I like the fact that you guys get immediate feedback and know if the graph's right or wrong. So, okay, have a good one. Email me, come to the office hour if you have any questions.